Now in the next step, what will we do? We can write it as y plus xy is equals to minus x. Take y common, 1 plus x. Y is equals to minus x upon 1 plus x. U upon v rule we will apply here. Differentiate with respect to x. Dy upon dx v square u dash v. U dash derivative of x is 1 into v minus v dash derivative of 1 is 0, x is 1 into u. So what we get here? Minus 1 plus x minus x upon 1 plus x whole square. X will get cancelled. So we get dy upon dx as minus 1 upon 1 plus x whole square. Note it down. Now the next one. If cos inverse x square minus y square upon x square plus y square is equals to tan inverse A, prove that dy upon dx is equal to y upon x. Now this term is given. First take x square common. We have left with 1 minus y square x square, 1 plus y square x square is equals to tan inverse A. Now here we have cos inverse. तो अंदर हमें cos की टर्म बनानी है so that cos inverse और cos cancel हो जाए. So put y upon x as tan theta. Y square x square is tan square. So cos inverse 1 minus tan square upon 1 plus tan square. 1 minus tan square and upon 1 plus tan square. This is the formula for cos of 2 theta is equals to tan inverse A. Cos inverse and cos will get cancelled. 2 theta tan inverse A. Theta is tan inverse y upon x is equals to tan inverse A. Is it clear up to here? Now tan inverse y upon x is equals to 1 by 2 tan inverse A. Clear? Now in the next step tan inverse यहाँ से remove करेंगे. So y upon x when it goes on right hand side tan of half tan inverse A. Now differentiate with respect to x. Y upon x, first function v square u dash into v minus v dash into u. This is the constant term, so derivative of this is 0. So x dy upon dx minus y is equals to 0. X dy upon dx is equals to y. So dy upon dx is equals to y upon x. Now next one. question number 7. If sin y is equals to x into sine of a plus y, prove that dy upon dx is equals to sine square a plus y upon sine of a. We have given this, differentiate this with respect to x. Derivative of sine is cos, derivative of y, u into v rule, first function as it is, derivative of sine is cos a plus y, then derivative of a plus y, plus sine of a plus y as it is, derivative of x is 1. So we get cos y dy upon dx, x cos of a plus y, constant term, a is constant, derivative of a is 0, y is dy upon dx, plus sine a plus y. This is of term of dy upon dx, and here also, so we can write it as cos y minus x cos a plus y dy upon dx is equals to sine a plus y. Now dy upon dx में हमारे पास x हमें नहीं चाहिए, तो हम x की टर्म पुट करेंगे. Let this equation as 1. From here the value of x will be x is equals to sine y upon sine a plus y. Here using 1 is equals to sine a plus y. हमने ये क्यों किया? क्योंकि जो हमें प्रूफ करना है आंसर में हमारे पास x नहीं है. Now in the next step take the LCM. Sine a plus y cos y sine a plus y minus cos a plus y is also here, minus sine y cos a plus y dy upon dx is equals to sine a plus y. Now this is the formula sine a cos b minus cos a sine b. What is the formula for that? Sine a cos b minus cos a sine b. Sine a minus b upon sine a plus y dy upon dx is equals to sine a plus y. This y will get cancelled, so we get dy upon dx as this term goes on the right hand side, so sine square a plus y, and this is sine a. This is what we want to prove. Note it down. Now the next one, if square root of 1 minus x power 6 plus square root of 1 minus y power 6 is equals to a into x cube minus y cube, prove that dy upon dx is equals to x cube x square upon y square square root of 1 minus y power 6 upon 1 minus x power 6, where and sin d. Sin theta, sin phi कुछ भी आप मान सकते हैं. Let it as sin theta and this as sin phi. Now 1 minus x cube is sin theta square. 1 minus sin square theta. 1 minus sin square phi. A sin theta minus sin phi. यही हुआ हमारे पास. 1 minus sin square is cos square. So we can write it as square root of cos square theta, square root of cos square phi into A into sin theta minus sin phi. So it is cos theta plus cos phi A into sin theta minus sin phi. We have formula cos C plus cos D, that is equals to 2 times cos C plus D by 2 cos C minus D by 2. This is the formula cos C plus cos D, 2 cos C plus D by 2 cos C minus D by 2. Here sin C minus sin D, 2 sin C minus D by 2 cos C plus D by 2. 2 will get cancelled. Cos theta plus phi will get cancelled. So we have left with cos and sin. Cos upon sin is cot. Theta minus phi by 2 is equal to A. Is it clear? So we can write it as theta minus phi by 2 is equals to cot inverse A or 2 cot inverse A. What is theta? Sin inverse x cube. Theta is sin inverse x cube and phi is sin inverse y cube is equals to 2 cot inverse A. Now differentiate it with respect to x. So in the next step, note up to here first. So in the next step, what we get? Derivative of sin inverse x. 1 upon square root of 1 minus x square. Here we have x cube, so derivative of x cube. 1 upon square root of 1 minus y square. Derivative of y cube. 2 cot inverse A is constant, so its derivative is 0. So 1 upon square root of 1 minus x power 6. Derivative of x cube. 3x square. This term goes on the right hand side. Derivative of y cube 3y square dy upon dx upon 1 minus y6. 3 will get cancelled. So dy upon dx x square square root of 1 minus x power 6 y square goes in the denominator and 1 minus y6 in the numerator. So we can write it as square root of this x square upon y square into square root of 1 minus y6 upon square root of 1 minus x power 6. Next one, if x square plus y square is equals to t minus 1 by t, x4 plus y4 is equals to t square plus 1 by t square, prove that dy upon dx is equals to 1 upon x cube into y. Now here we have given t square plus 1 t square and x power is 4, y power is 4. Now we have to squaring this term. A plus b whole square and here t minus 1 by t whole square. Clear? A plus b whole square. A square plus b square plus 2ab. Similar here, a minus b whole square. A square plus b square minus 2ab. Now we have value of this term t square plus 1 by t square, that is x4 plus y4. x4 plus y4 plus 2 x square y square. This will get cancelled, so we are left with x square y square is equals to minus 1. Or we can say that y square is minus 1 upon x square. Now differentiate both sides with respect to x. Y square, derivative of this 2y dy upon dx, we can write it as minus x power minus 2 minus n x n minus 1 minus minus plus 2 upon x cube. Now 2 will get cancelled. So we have left with dy upon dx is equals to 1 upon x cube into y. Next one is, if y is equals to b into tan inverse x upon a plus tan inverse y upon x, find dy upon dx. Find dy upon dx. Now we can write it as y upon b tan inverse x upon a plus tan inverse y upon x. Tan inverse इस साइड जाएगा, so it becomes tan y upon b x upon a plus tan inverse y upon x. Now differentiate with respect to x. Derivative of tan is sec square y upon b, then derivative of y upon b. 1 upon a is constant, derivative of x is 1, derivative of tan inverse is 1 plus x square, x is y upon x, so we will have to take the derivative of that also. So what we get? Sec square y upon b, 1 upon b is constant, derivative of y is dy upon dx. Is equals to 1 upon a, take the LCM here, x square plus y square, x square, u upon v rule, v square, u dash, derivative of y, u dash into v minus v dash, derivative of x into u. 1 upon b, sec square y upon b, dy upon dx, 1 upon a, this will get cancelled, plus 1 upon x square minus y upon x square plus y square. Is it clear up to here? So in the next step, what we get? 1 upon b sec square y upon b minus x upon x square plus y square dy upon dx is equals to 1 upon a minus y upon x square plus y square. So we get dy upon dx as 1 upon a minus y upon x square plus y square upon 1 upon b sec square y upon b minus x upon x square plus y square. Note it down.